Hey guys, today we're going to focus and talk about resistance. Resistance is caused by the free electrons that are flowing in a wire colliding with the atoms of the wire. And in the wire, resistance can affect the flow of current through the substance. Resistance causes the electrons to experience friction, which causes the conductor to heat up. So this diagram at the bottom shows us an example of molecules in a metal wire. And the electrons that flow through that wire have to flow around those molecules. They can't just fit straight through, they actually have to kind of follow a little path, and they have to create that path. Now notice two electrons may not follow the same path, but they always have to try to go around those atoms or those molecules in order to get through the wire. As this happens, every time that the electron moves and it bumps into a molecule, it causes a little bit of heat to build up. So when we have electricity running through wires, they feel warm or hot to the touch after a while, which is why they are covered in rubber. That rubber insulates them so it doesn't affect the surrounding areas. So resistance is the slowing of electrons based on the molecules in the wire as the electrons travel through the wire. Using this idea of resistivity, we can introduce something called Ohm's law. Ohm's law is the measure of resistance in ohms, which rhymes with homes, and it looks kind of like a horseshoe. It is a Greek letter, and that's going to be the unit for resistivity. So the formula for Ohm's law is V equals I times R. V is the voltage, I is the current, and R is the resistivity. Voltage is given in the unit of capital V, current is given in the unit of capital A, and resistivity is given in that horseshoe-shaped Greek letter. So when we calculate this, if we're solving for the V or the voltage, we're going to write down a number and put a capital V after it. If we're solving for the I or the current, we're going to write down a number and put a capital A after it. And if we're solving for resistance or ohms, we're going to write down a number and put this horseshoe shape behind it. Okay, so our first practice problem. What is the resistance of a lamp if it draws 0.25 amps from a 110 volt line? So just like normal, we have V equals, I equals, and R equals. V is 110, I is 0.025, and R is our question mark. So given our equation, we would have 110 equals 0.25 times capital R, divide both sides by 0.25, and capital R is 440 ohms. Not too bad, just simple algebra. Let's do one more. What is the current when a 5,000 ohm appliance is connected to a 110 volt line? So again, V equals, I equals, R equals. V is 110, current is my question mark, and R is equal to 5,000. I times R. Divide both sides by 5,000. And I is equal to 0.022 amps. Okay, so the first thing we're going to do is practice with this idea of resistivity and Ohm's law and do some math problems.